Hello and welcome to the BeagleScope project. The project that is based upon PRUSS version 2, open hardware platform BeagleBone Black and open source operating system Linux. The project's aim to develop generic, modular and ready-to-use pieces of code to deploy the PRUSS for interesting applications. The completed project will be useful for students, hobbyists, and electronic enthusiasts. Some example applications will be like a pocket oscilloscope or an ultrasound scanner. But what is PRUSS? The PRUSS, a programmable real-time unit subsystem, as the name suggests, is a subsystem in EM33XX processor. It contains two 32-bit real-time cores called PRUs. The PRUs are independent from the main processing unit. The cores are highly optimized for input and output operations. That is, they have no pipeline or caching system. This allows to develop programs with 100% predictable timings for internal peripherals. The instructions are also optimized, and most of them execute in just one single cycle. At 200 MHz, this is about 5 nanoseconds. Along with the PRU cores, the subsystem contains other peripherals like interrupt controller and a rich memory organization. This highly optimized architecture of the PRUs is what attributes to the fact that PRUs can toggle a GPIO at about 50 MHz. These two block diagrams provide some insight into the working and architecture of the PRUs. They can easily be found on the eLinux website. Enough about the PRUs. Now back to the project. The hardware that will be used for the project are ADC evaluation board marketed by ZeekHuge and BeagleBone Black. In theory, any parallel ADC can be used for the subsystem to work as long as we have the device drivers and the ADC supports the required sampling frequency. The ADC board shown here will be used in project for all testing purposes. So how will actually the project go? In its most basic form, the software system will show up the PRUs like a parallel bus. The complete software stack is shown and it contains bus driver that will manage the PRUs and communication with it, the subsystem which will be responsible for all the transactions to communicate the data parallelly, and then the device driver which will be based upon the ADC being used. This block diagram shows the basic working of the bus driver, and this is a high-level working of parallel offload subsystem. So, this was a small introduction to the BeagleScope project. I am Zabin Tolani, undergraduate student at Jabalpur Engineering College, India. I love coding and electronics. I have already worked on a number of embedded systems, Linux, Android, and iOS. I can be reached out at the links given below. This project is being developed under the Google Summer of Code 2016 program for beagleboard.org. My mentors are Kumar Abhishek, Hanir Yao, Stephanie Lockwood-Child, and Michael Waring. You can follow the project at the link given in the description. Thank you.